Okay, hello, this is going to be Solidworks CSWA practice problem 5.4. If you want to follow along, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. First of all, let's set the units to mmgs. Let's start a sketch, this time in the top plane. Keep in mind the part is asymmetric, so we will not be using mirror tool. So let's create a concentric pair, and we will dimension it as being the outer one will be 36 and the inner one will be 18, or yes, 18. Weird. In the drawing it says R9 for the circle, even though it's a circle. Kind of weird. But anyway, the diameter is 18, and then the outer one will be 36. And then you'll draw another pair over here somewhere. Just guess the location. And there'll be also another one over about a little higher, about here. Let's get those dimensions. The outer one will be 24. The inner one being oh, click the wrong one. Yes, the inner one being 12. And the other circle, the outer one is 16, and the inner one is 8. Then we will add a line like this, which goes into an arc, into another line, like this. And that line will be tangent with the circle, and the arc should also be tangent with the line. And then we'll create a tangent line connecting between these two circles, and same thing on the other side. Oh, this one did not get the tangency, and tangency. That should be it. Okay. We'll move the arc a little closer to the left side. So let's start adding our dimensions. So first, the angle between these two lines is going to be 18. Then this arc radius will be 42. And apparently, oh, I see. This line right here is actually a horizontal line. So make that horizontal. And then the angle between this diagonal and this horizontal is going to be 54. And the reason I knew this line was horizontal was because in the drawing this line was protruding from this line, making the 54 with the horizontal. And then there's also another angle between this diagonal and the same horizontal as before, which will be 22 degrees. And the distance between this center and this center will be 48. And the distance between this center and this center will be 82. That should be your fully defined sketch for the base. And now all we need to do is just trim entities, the axis of the circles. There you go. So let's feature extrude this. Do a blind extrude by 8. Now, before we continue, let's set 2 construction lines, which will serve as a reference for we'll set 2 construction lines that will serve as a reference for our reference planes later. Let's go back to the sketch. Click on line for construction. And these lines are just going to be parallel to the horizontal. And we'll do the same thing on the other side. Or perpendicular, I mean. And we'll set the distances. So the distance from this center to this line is going to be 34. And then the distance from this center to this line will also be 34. Now let's exit sketch. Let's make sure we're showing the sketch so we can still see those construction lines. And then we are going to, we're going to go to features, click reference geometry, and we'll make our first reference plane. Now we got a coincident reference with our construction line that we drew. Second reference should be this one, the top face. The plane will be perpendicular to this face. And we'll select OK. So let's start sketch here. Now keep in mind the plane is we're going to have to extrude this part outwards towards this circle right here, outwards like this. So let's draw the right side extrusion. And we're actually going to intentionally dig the part a little bit inside, like this. You can even start from the very bottom if you want to. Let's create a circular pair. Let's dimension the outside as being 24, inside as being 12. Let's make the circle tangent with this line. Let's add a coincident between the point and the circle. There we go. And then a diagonal that's digging into the part. And the reason why you have the part digging into the part is so that when you make the final extrusion, the diagonal part isn't, how to say, like floating. It's not going to be floating. You want to make sure it's dug into the part so it's fully, so that it's fully coincident with the top surface. And then let's add our dimensions. So from the very bottom to center point will be 48. And we can just pull this down. Actually, we can make this coincident with the bottom edge. It doesn't make a difference. So let's make it coincident. And then let's add a angle between diagonal and vertical line as being 78. 78, that can't be right. $78. Maybe I'm reading the angle wrong. Oh, I see. Oh, wait, no. The angle is actually between this diagonal and I believe the bottom edge, like this. Oh, yes. That's what it is, 78. Okay. Huh. The other one would have been way too big. And yes, that's fully defined. And we can use trim entities. And then that should be it. Let's extrude this. It should be extruding this way. And it will be extruded by 6. Is that okay? And we're going to more or less repeat the same exact process for the next side. So reference geometry, plane, center line, top face. Okay, start a new sketch. Going to repeat the same process. The inner circle will be 8. The outer circle will be 16. 16, yes. Tangency. Coincidence. And finally, the diagonal line. That's also tangent. And close. The distance from bottom edge to center is going to be slightly different. Instead of 48, it will be 46. And angle between bottom edge and diagonal will be 74. Trim away the rest of the circle. And let's extrude this. Be very careful here. It's extruding the wrong way. You need to reverse the direction. Because earlier we did 34. Because this right here where the line is, that's where the center line begins. So it has to be extruded to the left. So 6 millimeters extrusion. Select OK, and that should be the whole part. Let's hide this plane. And for your mass properties, you should have a volume of 54,372 cubic millimeters. I hope you learned something from this video, and I'll see you in the next one.